variation in G. See, it is Earth, it is radius R, okay, its center O, it is surface point A. At point A, G on the surface of the Earth, that is G equal to capital G M by R square. Capital G M by R square. So G on the surface of the Earth, that is G is equal to G M by R square. Okay. Now G at a height h. At point B, we have to find G at height h. That is equal to how much? So here we have formula G on the surface of the Earth, that is G equal to Gm by R square. Here G at a height h. G at a height h. G at a height h. Here the first case, if height is greater than radius of the Earth, then G at a height h, Gh is equal to Gm by, okay, R place from the center to point B. In the place of R, we have to write distance of this point B from center, that is R plus H. R plus H whole square. Okay, then I will write R square outside, then I will get Gm by R square. If I write outside, then I will get 1 plus H by R whole square. Then Gm by R square means here G on the surface of the Earth, so I will get G by 1 plus H by R whole square. If H greater than R, then we got G at a height H. What is the formula? We can write Gm by R plus H whole square, or we can write G by 1 plus H by R whole square. Yes. For suppose if this H is equal to R, then what about G at that height H? If H is equal to R, then what about G at height H? G at height H is equal to, see from above equation we have G at height H is equal to G by 1 plus H by R whole square. In this place, I will substitute H place R. So R by R whole square, then R cancelled, then 1 plus 1 whole square I will get, that means G by 2 whole square means, then I will get G by 4. So if H is equal to R, then G at height H is G by 4. G at height H is G by 4. Case 3, if H equal to R by 2. If H is equal to R by 2, then G at height H, that is G at height H, what? So in this equation, that is G at height H, when H greater than R, what we got? G by 1 plus H by R whole square. In the place of H, if I place R by 2, then what I will get? Look at here, G by 1 plus H plus R by 2, okay, R by 2 by R whole square. So R cancelled here. So I will get G by 2 is the LCM. So I will get 3 by 2 whole square. Then if I simplify, I will get 4G by 9. So I got, if H equal to R by 2, then G at height H, that is 4G by 9, my dear. Next case, if H much less than R, then what about G at that height H? We will go with next page. What is that? Here, if H much less than R, H much less than R means I will take point B is here. Okay, this is point A and this is O. Okay, so here I will take distance of point B from O. Okay, here if you observe means here H much less than R. Okay, R is the radius, you know that. If H much less than R, then what about G at this height H? So we have G at height H, if H greater than R, that is G at height H, if H greater than R, what is the formula? In previous page we got G by 1 plus H by R whole square. Okay, G by 1 plus H by R whole square. Okay, if H much less than R, if H much less than R, then what about G at height H? I will move this 1 plus H by R whole square to the numerator, then I will get G into 1 plus H by R whole power minus 2. Okay, then from binomial expansion I can write this one 1 minus 2H by R. How it came? Since we know that from binomial expansion 1 plus x whole power minus n means 1 minus nx. Okay, then we got G at a height H, if H much less than R, that is G into 1 minus 2H by R. Now we will calculate G at a depth D. Okay, I will take next page. I will take one point A on the surface of the earth. Okay, and it is center O. Okay, so here I will take radius. It is radius. We have to calculate G at depth D. So here the distance of B from center, that is R minus D. This distance how much? The distance of B from center, this distance is R minus D. R minus D. Okay. Now we have to calculate G at depth D. Okay. So we have formula for G on the surface of the earth, that is at point A, which is on the surface of the earth. That is what? Gm by R square. Okay. So here G by R square. Mass I will write in terms of volume and density, that is 4 by 3 pi r cube into density rho. Here this r square r cube cancelled, then what I will get? I will get 4 by 3 pi rho g r. So this is another form of G, that is 4 by 3 pi rho G R. It is on the surface of the earth. G at depth D, that will be 4 by 3 pi rho density G into this distance from center to B, that is R minus D, my dear. Okay. Now this is equation 2 and first one equation 1. Okay. Now do 1 by 2. 1 by 2 if you do means, then what will you get? You will get G by G at depth D is equal to, you will get 4 by 3 rho G cancel, then what will you get? You will get R by R minus D. Okay. Then do cross multiplication. If you do cross multiplication, what will you get? G into D into R is equal to G into R minus D. Okay. Then move this R to the right side, then you will get G at depth D, that is G into 1 minus D by R. So this is formula for G at depth D, my dear students. So what about G at center? G at center D equal to R, G at center will be 0. Why 0? Because D equal to R, so both will be cancelled, then 1 minus 1, 0 we will get. So G at center will be 0, since at center D equal to R. Due to that we will get 0, my dear. So that's about this session, my dear students. In this session what we found? We found variation in G at a height h, next at a depth D. Okay. I hope you like this session. If you like it, please put like. Thanks for watching my video. Bye students.